Dear viewers, there are many situations when we are confronted with complicated logical problems, and we have to devise sophisticated strategies to solve these problems. In such cases, you may want to consider the strategy pattern. This pattern consists of an interface defining a set of functions common to all the strategies we are about to use. In our example, we will create a ground price calculator having a compute function. This calculator will know how to use an interface in such a way that the resulted price will be depending on a strategy based on the place of the seller. If we would create such a logic directly in ground price, we should do something like this. Use a private variable seller from, defining the place from where the seller will be. Then our function calculate will base its logic on the place of the seller. If the seller is from USA, we will have a set of logic. If it's from somewhere else, we will have other logic. Let's say that we also got the price as a parameter. We will use an internal variable, ground price, which at the beginning will be equal to the parameter price. After comparing our seller from to USA, we will decide that our ground price has to be incremented or decremented by a discount provided by the discount USA private method. Next, we will imagine that our ground price also has to be adjusted for taxes. So we will call the USA taxes on our price. Finally, we have to convert our price into the currency of the seller. In our case, it will be a conversion to dollars. So far, nothing exceptional. But if we continue with this logic, we will see that if our user is from Europe, then we will have a very similar logic. But instead of calling the taxes and discount and dollars on a USA method, we will have to implement a discount for Europe, a taxes for Europe, and the conversion has to be done to euro. And the logic does not have to stop here. What if we also are operating in the Asian market? So, if our seller is from Asia, then we will have to do the same methods again and again and again for that specific area. Imagine how sophisticated an implementation like this will be if you have 6, 7, or even hundreds of places where you have to calculate all these things differently. And all the logic concerning these computations will be in the ground price class. This is a lot of logic for a single class. Let's just do the implementation for the 6 methods above to exemplify the extent of the code. After just completing the first 3 methods, our class already does not fit in a single window. We are at 31 lines and we are continuing. At this point, we passed already 42 lines. This class is getting big. Please note that I did only one-line implementations for each method. In a real life, these computations would be much more sophisticated depending on our logic. And I also missed that here should be discount Europe. So we have more than 20 lines doing a logic that does not really concern by the grant price and by a calculator. It is more likely related to a class or an object which is connected to a place, to the seller's place, and not to the computations regarding a price. Of course, the class will have to do these computations if we move these methods there, but it can provide all this information as a strategy and unknown to the grant price calculator here. So what will we do? We'll go to our price calculator, which is an interface that has 3 methods: the apply discounts, the add taxes, and the convert currencies. This interface then can be implemented by several other classes based on the user location. Such a class would be the Europe pricing strategy. To implement this, we can take whatever we wrote before in the grant price for Europe and move everything from here into the Europe pricing strategy. Of course, the classes have to be public. Then we will specify that the Europe strategy implements price calculator. We see that we have a little problem. Our method names does not concur with the interface. Let's see what is wrong. Well, we have names for specific locations, like discount Europe and euro taxes and convert to euro. Let's say euro taxes will be moved to add taxes. At this point, we also should consider renaming the functions in the interface to better suit our situation. So instead of calling add taxes, we may probably want to calculate the taxes. And we will also have to provide a price. We will also have to do similar adjustments to the other methods. Let's do them here and then modify our interface. The apply discount would be returning the -10 from the discount Europe, and we should just call it a negative discount, so that it is clear that we add this value to our price. In the real world, this value could be different, not just a returning line, based on price. For example, if we are implementing the Europe pricing strategy and our price is larger than 1000 euro, we should consider offering a discount of 100 euros. Otherwise, only just 10. Similar strategies and computations would be implemented in other methods also, if this would be a real size application. But for our example, let's just go on with what we have. Convert to euro also will just be transforming convert currency of price And then we will modify our interface, the price calculator, to reflect our newly defined methods. Convert currency of price, calculate taxes of price, and negative discount of price. If at this point we go back to Europe pricing strategy, you can see that we no longer have a problem with our class. It implements the right methods in the right way. The next step is to go back to grant price and take whatever we have for USA and move it in another class, the USA pricing strategy. This class also should implement the price calculator and all its public methods. And here we will paste all the information we already had. Discount goes to negative discount. Taxes go to calculate taxes. And convert to dollars go to convert currency. We delete the old methods and we have a second class with a second strategy doing all the stuff. Now, back in our grant price calculator, what we can do is expect a second parameter, not only the price to calculate, but a strategy to use to do so. To be sure we are getting the right object, we will force this to be a price calculator type. Now, instead of using all these if statements and calls, we will delete everything because we know that all the knowledge about how to calculate these pricings and taxes and discounts come from a pricing strategy. So, we will add to our grant price the pricing strategy get a negative discount of our price. We'll do the same for the taxes. Finally, we will convert our grant price into the required currency. This will also happen by using the strategy provided instead of guessing based on a location. As the last step, we will return our newly computed price. As you can see, this logic made our class much more simple, and if from the exterior someone wishes to calculate a price, it will simply provide the price calculator strategy to which the user belongs. It is no longer the responsibility of the grant price to guess what to do with a user based on its location. It is the responsibility of the caller to call it with the proper pricing strategy. Also, there is absolutely no logic about how these calculations are made. All the location-dependent calculations are done in their own classes, as in the USA pricing strategy and in the Europe pricing strategy. If you use this pattern, you can observe that if in the future we will sell products to other parts of the world, implementing a new strategy will be very simple, and using that strategy in the rest of our application will be transparent. Our new grant price calculator will never know that it is using a pricing strategy that existed now or it was created 3 months from now. It doesn't care. All it has to know is that there is a strategy which has a set of methods, and if a price has to be computed, it can be done using that strategy. As a final note, I would mention that wherever you need flexibility, for complex logic, where duplication is also a problem, a strategy pattern can come in handy. Use it when you think you have to do several steps in different ways and the decision is complicated. That would be all for this episode. See you next time. Bye.